So, section 2.6, solving radical equations. The basic rules. What is the opposite of a square root? A square. A power of 2, right? So taking something to the second power would be the opposite of a square root. So, for this example here, square root of x equals 25. What could I do to get rid of that square root? Yeah, just square it. But if I do that on the left, I also have to do it on the right, correct? Yeah, so on the left, those two things cancel to just give me the radicand, which is x. And then what's 25 squared? Get a calculator out. 625, good. Okay, so sometimes we don't just have squares and square roots, okay? Sometimes we just have rational powers. And we know that the square root of x was the same thing as x to the 1/2, right? And so when we squared that, we just took it to the second power, which is the same as 2/1. What do we call those? 1/2 and 2/1.
Reciprocal.
Reciprocal, good. A good math word. Reciprocal. Okay? So looking at this next example, how would I get rid of that x to the 3/2? What should I do there? To the, haven't heard it yet. Reciprocal. 2/3. So I would do that on the right as well. So 3/2 times 2/3, can we all agree that is 1? Yes, it is. And 25 to the 2/3, you can literally type that in your calculator, just 25 caret 2 ABC3 somebody 6. It's not what you got? I don't think that's right. 8.5? Okay, we'll go with it. That would be your answer. All right, so at the bottom it does say hint, this is power to a power rule. We dealt with that in the last unit in 2A, okay? We know we multiply the powers. That's how we do that. Okay, so now we're going to be moving into equations involving these radicals, and we're going to be graphing them. Today we're just going to deal with solving the equations and dealing with finding the domain, okay? So even roots, we know that those cannot be negative. They can't have a negative radicand, right? Or else it becomes imaginary. So what we've got to do to find the domain is just set that greater than or equal to 0, because we know that it's always going to be positive, okay? But if our root is odd, it's just always going to be negative infinity to infinity, okay? So again, domain is which axis? Isn't it the x-axis? Don't we look from left to right where it's going? Okay, so make sure we know that and we're clear. Domain is x-axis, which isn't super important today, but it will be when we start graphing. Okay, so again, if it's an even root, set it greater than or equal to 0. So set radicand, this is kind of a typo, greater than or equal to 0 and solve. But if it's an odd root, it's just always going to be negative infinity to infinity for the domain, because we know that those can go all the way across the graph. They can be negative and they can be positive. Okay? And the other thing that I want you to write down here is always find domain first if it asks for it. So always start with the domain. Okay. These actually aren't not too bad, so I don't think you're going to be crying today, which is good. So looking at this first one, the domain. All I'm looking at to find the domain is the square root, or the root, whatever it's going to be. So square root of x, is that an index? Looking at that index, is that positive? Sorry, it is positive. Is that even or odd? It's even, right? Because it's a square root. So That means I just need to set everything under the root symbol greater than or equal to 0. If I had to write that in interval notation, it would just be this, 0 to infinity. So that's it on the domain for that one. Now to solve this, I just treat it as if it were any other equation. I've got to isolate the root on one side and get everything else on the other. How would I get rid of that 3? Subtract it. I just have the square root of x equals 7. How do I get rid of the root? Square it on both sides. So I get x equals, what's 7 squared? 49. That's it. That's my solution. That's how these work. Questions on that?
Why did you put the domain as the 0 and infinity?
Because it's x is greater than or equal to 0. So when you write that in interval notation, it starts at 0 and it goes to infinity. Yep, good question. Okay, number 2. Looking at this one. First we'll start with domain. Even or odd root? Even, how'd you know that? Because it's a square root. So I'm just going to take that whole radicand and set it greater than or equal to 0. How do I solve that? Plus 2. So 3x is greater than or equal to 2. Now what? Divide by 3. So x is greater than or equal to 2/3. So how would I write that in interval notation? 2/3 to infinity. So domain is done. And now we just got to solve this. So go ahead and try that. All right, what did you do first? Ooh, can we distribute to a root underneath a root? No. What do I need to do with that 2? Subtract it. It's being added. So then I just have my root equals 4. Now what? Is that my answer? No, what do I need to do? Square it. On both sides. When I do that, again, the sign and the 2 just cancel out to just give me the radicand. And what's 4 squared? Good. And now that's pretty easy to solve, right? Add 2 over. 3x is 18. Divide by 3 and x is going to be 6. That is all. Questions on that? Okay. Now, we're going to move down. Sometimes we have indexes other than 2, and that's okay. Okay? So given the following equations, solve them and state the domain. Looking at the first one, odd or even root. What'd you say? Even. Why is it even? Because it's a 4th root. It is a 4th root, so that is definitely going to be even. So what do I need to do? Set what greater than or equal to 0? Yep. And then just solve that. Add 1 over. 2x is greater than or equal to 1. Divide by 2, and x is greater than or equal to 1/2. So in interval notation, what's that going to be? 1/2 to infinity. And now we just solve it. First thing, yep, divide by 8, because that 8 out front is being multiplied, and we cannot distribute underneath of a radical. Don't try to do that. So we end up with the 4th root of 2x minus 1 equals 3. 24 divided by 8 is 3. Okay. To get rid of a fourth root, what power would I need to take both sides to? The fourth. The fourth. A fourth root is the same thing as the 1/4 power. The reciprocal of that is 4. So both sides need to be taken to the fourth power. When I do that, the symbols on the left just cancel to give me 2x minus 1. And then I type into my calculator 3 to the fourth power, 81. Now what? Just add the 1. 2x is 82. What is x? 41. Then it just says to check it. So sometimes when these problems start getting big, okay, it's good to always get in the habit of checking your answer, either by using a calculator or just by using your head, okay? So if I go and I plug in 41 for x, well, I know 41 times 2 is 82, minus 1 is 81. If I fourth root 81 in my calculator, I should get 3, because the fourth root. And then 3 times 8, is that 24? Yep, so feel free to write that out if you need to. If you need to write out the problem just to check it and make sure that it works, then do so. But you can always just check it in your calculator. And as long as it's good, you're good. Okay? Questions on that? All right, go ahead and do example 4. All right, is this odd or even? Odd, because it's a third root, right? And 3 is odd. My index is 3. What would the domain be? Yep, negative infinity to infinity, always for an odd root, okay? If your index is odd, you don't have to do any work. It's just automatically that. But you do have to do some work to solve it. So let's go ahead and solve this one. How would I do that? Yep, subtract the 8 over. I have the third root of 5x plus 1 equals negative 4. Now what? To the third power. Good. On the left side, I end up with 5x plus 1 equals negative 64. Good. Subtract the 1. 5x is negative 65. And what's x going to be? Negative 13. Then if you check that in your calculator, what is 5 times negative 13? Negative 65 plus 1 is negative 64. If you cube root that, you should end up with negative 4 plus 8, which should be 4. So good deal. Questions on that? All right. Number 5. It says, solve the following problems dealing with rational exponents. Okay, we've seen these before. This was in 2A. Rational exponents. So basically, if I rewrote this problem, would you agree that this is the same thing as 2 times the cubed root of x minus 2 squared equals 50? Wouldn't that be the same thing? Okay, so when you see something written like this, don't get super confused and think that you're not dealing with a root anymore, okay? Because you still are. I would prefer that you just leave it written like this, but if you feel the need to write it out like this, that's totally fine too, okay? And what we've got here is what is our index? What's the index? 3, right? So if you are looking at a rational exponent, Would you agree that the index is always going to be the denominator? Haven't we talked about that? Yeah, so just look at that number. Is it odd or is it even? It's odd, so what's the domain going to be? Yep, negative infinity to infinity. So we got the domain, now we just have to solve it. Okay? So to solve this, what do I need to do? How do I get the root by itself? Yep, we got to get rid of that 2 out front because that's not a part of the root. When you do that, you just get x minus 2 to the 2/3 equals 25. Okay, and just like the one that we did in the first part of notes, I've got to use my reciprocal. I heard somebody say it. What would the reciprocal be? 3/2. Okay, now everybody pause here. So this is the one tricky part of this section to remember, okay? When you get to this point and you take your reciprocal and you raise it to that power, okay? Technically what I'm doing here is I am raising this 25 to the 3/2 power, which if I had to rewrite that, it would look like this. Correct? Okay, so if I were to go and I break this down, so I would get 25 to the 3rd would be what? Let me see this real quick. 25 to the 3rd is a really big number, okay? And then if you go ahead and square root that number, 15,625, you end up with 125. Okay, so that is what 25 to the 3/2 power is 125. But here's the thing. Because this is a 2, technically wouldn't negative 125 times negative 125 also be that same number? You see what I mean? So the way these are going to work, and what I need you to write down at the bottom, is that you always need to use plus or minus when dealing with even roots. When dealing with even roots. And those even roots are going to be when you take the reciprocal. So write that down. So if you take the reciprocal and the bottom of it is even, you're going to have to do a plus and minus. And how that works is it's not as difficult as it sounds. Okay? When I go and I take this reciprocal, on the left side, it's still going to cancel out, okay? On the right side, when we typed in that 25 to the 3/2 power, and you can literally just type that in your calculator, so do that. And I even already told you the answer. It was 125. So it's just going to be a plus or minus 125. Okay?
So it could be either?
So it could be either, but I've got to make sure I know what x equals for both. So I just need to do x minus 2 equals 125, and x minus 2 equals negative 125. Add 2 over, x is 127, and when you add 2 over, x is negative 123. So those are your two answers. That's your solution. You with me? Somewhat. We'll do more. So when you take that reciprocal, if that bottom number is even, you've got to use plus or minus. So you're just going to have two answers. Okay, and then it says to check that. So if I go up and I plug those in with my calculator, so I can literally just type in this whole first sentence. If I type in both those numbers, they should both come out to 50. Okay, so if you want to try that real quick, go ahead and do it. There are going to be some things moving forward in Algebra 2 that don't end up equaling 50, okay, or equaling that number. And those are what we call extraneous solutions. I don't think there's going to be any extraneous solutions on the test, but I will let you know if there are. okay? So let's go ahead, move down to example 6. What's different about example 6 than example 5? Just by looking at it. They look pretty similar. What's different? Yeah, example 6 is to the 3/2 power. So currently my index is even, so we know how to find the domain of an even root. When I take the reciprocal on this one, do you think I'm going to have plus or minus? No. Why? Because it'll be 2/3 and is 3 even? No, so I wouldn't need a plus minus. So go ahead and try this one. So you are going to have a domain other than negative infinity to infinity, and you're not going to have to do plus minus on this one. So try that out. Okay, so we'll start with domain. What'd you do? What'd you do for domain? Good. That's my radicand. Just set it greater than or equal to 0. Solve it. X is greater than or equal to 2. And how'd you write that in interval notation? 2 to infinity. Good. And now, time for solving it. What'd you do first? Divide by 2. So I get x minus 2 to the 3/2 equals 25. My reciprocal, 2/3. Is this number even? No, so I'm good. I don't have to worry about plus or minus. So this is just x minus 2. When you type in 25 to the 2/3 power in your calculator, what do you get? 8.5. And then add 2. So x is just going to be 10.5. And you can go ahead and check it if you want, but that one should also work out. Okay? Anybody have questions on that? All right. Go ahead and try this one on your own. You can work with somebody around you as well. Okay, so starting off with the domain. Even or odd? Even, right? Because the index is 4, and 4 is an even number. So what do I need to do? Yep, set 9x plus 9 greater than or equal to 0. When I do that, subtract the 9 over. 9x is greater than or equal to -9. Now what? Divide by 9. So x is greater than or equal to -9. When you wrote that in interval notation, what'd you do? -1 to infinity. Good. Now it's just time to solve this. What'd you do, Tate?
Added 1 or 2.
Add 2, yep.
And you multiply both sides by 4, or the 4th exponent.
So take it to the 4th exponent, yep. What's the left side become?
81, or just 9x.
9x plus 9 equals 81. Raise your hand if you got that far. Good. Now what?
Minus 9.
Minus 9. So 9x is
72.
72. And what's x going to be? 8. That is your solution. And if you go back and check it, you can literally just plug it into your calculator and plug in 8 for x, and it should work. I would always get in the habit on quizzes and tests of just going ahead and doing that, just because if you don't get the right answer, it probably means you did something wrong, okay? So that's always a good habit to get into. Because sometimes we make little mistakes and then it ends up costing us a lot of points. Okay, so if we can save ourselves from doing that, then we'll be golden. Okay, now we're going to be solving equations with two rational exponents. So when solving with multiple radicals, you must isolate each radical on both sides. So one needs to be on one side, the other needs to be on the other. Okay, and then step 2 says to find a multiple, or find a common multiple to use as a power of both exponents. Honestly, this one's not going to be super important today, so don't star it, maybe like exit, just because on the quiz and on the test for this chapter, you're only going to be dealing with radicals that have the same on both sides, and I'll show you what I mean by that. But whenever you get into like Algebra 3 or college algebra, then you might have to deal with the common multiple thing, but we're not going to have to deal with it this chapter. Okay, then you solve it like normal. Sure. So, example 1. So what I've got to do is I've got to get one root isolated on one side and one on the other. So to do that, I'm just going to add this one over since it's negative. So I'm going to add it over to the other side. And when I do that, this is what I end up with. Square root of 2x plus 1 equals square root of 3x plus 4. You with me? One thing I forgot to mention, on these ones we don't have to do domain. It's not going to ask you for that on the quiz or the test, so don't worry about it. Okay? So what are my indexes on both of these? They're just 2. How do I cancel out a square root? Square it. When I do that, the square and this sign cancel to give me just 2x plus 1 equals 3x plus 4. Then you just solve it. Okay? These ones are really easy. I think they're easier than the other ones, to be honest, but subtract the 2x, subtract the 4. X is negative 3. That's your answer. Okay? When I go plug this back in, if you include the square root symbol in your calculator, it's going to give you a domain error, okay? But really, I can just do this one in my head. What's 2 times negative 3 plus 1? Just negative 5, right? So the left side equals negative 5. And then what's 3 times negative 3? Negative 9 plus 4. Negative 5. Do those two things equal each other? Yeah. Even though they're going to be imaginary, they still equal each other. So this one works. Okay? Go ahead and try example 2. Go ahead and do 3 as well. All right, number 2, what'd you do? What was that? Yep. Add the square root of 5x minus 25 on both sides, so you end up with this. Raise your hand if you got that far. Sweet. Now what? Square them. What's that do? Yep, just drops everything, right? When you solve this, what'd you get? X is negative 5. And if you plug that in, you'll get square root of negative 50 equals square root of negative 50. So it's good. Questions on that? Number 3, what's going to happen here? Square them both. What does it become? Aren't these easy? Yeah. Solve it. add 4n, right? So 2n equals 6. What's n equal? 3. If you plug that in, it should work as well. Okay? And then down here, I've got a fourth root. It's also even, right? How would I cancel out a fourth root?
Fourth power.
To the fourth power. So can't I do that on both sides? What's going to happen? This is going to cancel and give me 7w minus 5 equals
W minus.
solve it. 6w equals, and what's w equal? 1/2. If you plug it in, it should work as well. No reason we're missing this on the quiz. Right?
Yes.
Pretty simple. Cool. This is a test question. Star it. The average profit of a company in millions per month from 2001 to 2008 can be modeled by the following equation, where X is the number of years since 2000. In what year will the profit be 12 million? Okay, so they told me X is what? The number of years, okay? So do you think it would be logical for me to plug in $12 million into X? No. Why? They're not the same thing, right? We got to pay attention to labels on this one. So if I can't plug in 12 million for X, where do you think I should plug it in? Y. It's the only other place to plug it in, okay? And they told me that Y is average profit, and they told me the 12 million was a profit, right? So it would make sense to plug it in there. Okay, the only reason this gets a little bit confusing, it says in millions per month. So how many million is 12 million? 12. So really this is just going to be 12 equals. And I screwed that one up in front of my first hour because I put in 12 million because I didn't read the question on a Monday morning at 7:15. Okay, could we solve something like this? Yup. What do I do? Divide by the 4.5. What's 12 divided by 4.5? 2. Let's just call it 6.7 equals square root of 1.2x plus 1.05. Now what? Square it. Got to get rid of that square root. What is 2.67 squared? It's going to be an ugly decimal. .76 equals, you typed it in wrong, what is it? 6.71. 7.1. Got it. 7.1 will work. Now what? Minus the 1.05. What is 7.1 minus 1.05? And what's x going to equal? Divide by the 1.2 on both sides. This is 5 point something something.
5.041.
Okay, so 5.04 million, how about we just call that 5 million? Sound good? So on the test, you could just put that. 5 million. $5 million in profit. Wouldn't that be nice? All right, cool. So that's it for today. There is a quiz next class over just this stuff, okay?